So today I'm speaking from home, so please pardon if you hear children in the background. Okay. We have ice storm and probably most of the country also does. Now, before we get started, very briefly my introduction, because I'm supposed to say that every session. So basically, I have a degree in electrical engineering from Virginia Tech, and I have worked for Nortel and Valve for 7 years. I have been teaching for our solutions. The technologies I teach include LTE, WiMAX, UMTS, HSTA, and 1X video. So hopefully you are able to hear me okay. So today's session will be focusing on interworking.
Nishit?
Yes.
Yes, I don't hear you very well. It's very bad, in fact.
Oh, okay. Sure. Okay, I will try to do that. Okay. Okay, how about now? Is that okay now?
A little better, but still not very.
Oh, still okay. Let me try to do something. Okay, give me a few seconds.
Nisha,
Is it better now?
yeah, you may just need to speak up more.
Okay. How about now? Is that okay?
Yeah, it's better. Yeah.
Better?
Yeah.
Okay. I will shout, okay?
Thank you.
Okay, sure. Okay. So today we will talk about interworking between LTE and 3GPP family of standards. So basically, with interworking with UMTS, GPRS Edge, like that. And here are the main topics that we would be covering. Let's say we have a UE that is powering up in a UMTS only coverage area, and then the UE tries to do data transfer. So before data transfer, we would have to activate the PDB context. So when the UE is trying to do PDB context activation, instead of using traditional UMTS core network, now we will start using EPC, Event Packet Core. So for example, okay, looks like someone has okay. So for example, traditionally we have SGSM and GGSM involved, but now we will start using PGW, PDM gateway, to help us with PDP context activation. We will talk about the interworking between LTE and 3GPP when the UE is in the connected mode. Okay. So in that case, we would be having some handover decision made by the network. So we'll talk about that. Also, when the UE is in the idle mode, as it goes from one area to another, maybe LTE to a non-LTE area, so then the UE would be doing cell reselection to another technology. So we'll talk about that as well. We will talk about the network architecture, various new interfaces that have been designed. An example here, just S4, there are many interfaces we would talk about. So that's what we would be covering today. Before we get into the material, if you could please give me some feedback here, about 30 seconds.
Nishith, are you using handset or headset?
Actually, this is my sort of speakerphone landline. Okay, let me do this. Let me get rid of the speakerphone. Okay, hold on.
Okay.
Okay, is this better?
Oh, much better.
Oh, okay. Okay, let me do this. Okay.
Thank you so much.
Sure. Okay. So 10 more seconds to go. Okay, about 40% system test integration, about 35% customer support, quarter in systems engineering. Thank you. One more question and we will be on our way to discuss interworking. Please participate in all the polls. This will help us figure out the degree of details we should discuss. Okay. Okay, so almost all of you concepts and some details. Okay, very good. Okay, first, architecture. So how LTE and existing UMTS networks would be connected to each other. Now, when we started defining the requirements for the architecture, we had certain goals in our mind, and these are the goals that we are mentioning here. So we need to support handover even across key elements. We should have optimized active mode mobility, so that will help us reduce the handover delay. And in terms of charging, we should support both online and offline charging. In one of the previous sessions, we talked about charging. Basically, we have PCC, policy and charging control, that helps with quality of service and charging. And we have online charging system, offline charging system. They connect to the PCC. Idle mode mobility. So if the UE does not have a radio connection, then it will still be able to go between the technologies. That will be through cell reselection. Quality of service. Now, in UMTS, we have 4 levels of quality of service. If you recall, conversational, streaming, interactive, and background. In LTE, how many levels of QoS? Do you remember? How many levels of quality of service? How many QCIs do we have? You can type your question. Okay, very good. 9, excellent. Thank you for your responses. You are already awake. Very good. Okay, 9 levels of QoS. So we have basically 4 levels of QoS in UMTS and 9 levels of QoS in the LTE system. So when the user is going between 2 technologies, then we have to do some kind of mapping of quality of service. So we would do that, and we would try to not have any kind of packet data loss during the handover. So one option there is to forward the packets. So let's say we go from LTE to UMTS. Then the LTE can forward the IP packets to the UMTS network so that we have 0 packet loss. So that kind of functionality is available. while we are trying to ensure smooth interworking between the technologies, we do not want to have too many changes in the existing systems. So we have tried to minimize the impact. And in terms of voice, we should have good quality before handover, during handover, and after handover. So that's voice. Authentication, so basically we will be relying upon the traditional UMTS authentication when we are thinking about interworking across the technologies. So those were the requirements for inter-radio access technology mobility. Now, in general, we have two kinds of options for interworking. One option is where we upgrade our SGSNs to understand LTE, understand release 8. So it means that you have to spend a little more money upgrading those SGSNs, so you can expect slightly better performance. However, there is also another option where SGSN has no impact. So you keep SGSN the way it is. And in that case, we still have interworking. Performance would be slightly worse, but that will save money. Now, in a typical environment, we may have in some geographic areas upgraded SGSNs, in some geographic areas SGSNs that are not upgraded, but that is fine. An operator may have a mix of this, but no problem. Now, if you upgrade SGSNs, that kind of interworking would be through so-called S4 SGSN, because there is a special interface between LTE and UMTS, and that would be called S4 SGSN type interworking option. And if you have not touched SGSN, it would be called GN SGSN type SGSN. And those are the two main types of SGSNs we would have. Okay, now what is this S4 SGSN? So here is the existing UMTS or GPRS network, and that SGSN has been upgraded to understand release 8 LTE. The way we derive the name S4 SGSN is that it talks to the serving gateway through the S4 interface. That is the key. That's why it is called S4 SGSN. It understands that there is something called serving gateway, and I'm talking to that serving gateway via S4. So SGSN knows about that. And we have an additional interface, S3, that is with the MME. So SGSN knows that I am talking to MME via S3. So those are two interfaces the new upgraded S4 SGSN understands. So those are the two links associated with S4 SGSN. It is possible to have so-called direct tunnel between the RNC and SGW, serving gateway and RNC. That interface is S12. Okay, S12. Now, have you come across the term direct tunnel architecture for UMTS? What is the main benefit of direct tunnel architecture? This is basically defined in Release 7 as an optional architectural enhancement. answer on the Q&A box. Maybe I should give you little information about so-called directional architecture so that you appreciate what is happening here. Okay, let me draw a picture. There is something on the Q&A box, packet forwarding. Okay, let me explain directional architecture. So as I mentioned, it is defined in Release 7 of UMTS. So the basic idea is the following. We want to bypass SGSN for user traffic. So it means that the only thing that SGSN is doing now is signaling. User packets do not travel through SGSN. So let's say we have a user doing web browsing. Then the packets would first arrive at the GSM, and directly from GSM, the packet would go to RNC. SGSN is not involved at all. So the user packets are traveling from core network GSM to the RNC. So in this case, if SGSN is not in the picture for user traffic, then what kind of benefits do we get? One benefit is that it will reduce the overall cost because we need fewer SGSNs to support a given geographic area. Normally, if you do not have a directional architecture, then our SGSN has to support both the signaling and user traffic. So you need to carry signaling load and user traffic both as an SGSN. So it means that if there are a lot of users, a lot of user traffic will be there. So we would need many SGSNs. On the other hand, if SGSN takes care of only signaling, then you can provision the number of SGSNs purely based on the signaling load. So you need a lot fewer SGSNs to cover a given area. So that will reduce the cost. There is one additional side benefit. The delay will also go down because we have one less node to pass through. So that is the idea. That in directional architecture, the SGSN is not taking care of the user traffic. The user traffic flows between the RNC and GSM. That is the directional architecture. So what we are doing here in LTE is that optionally we can support that kind of directional architecture where we have RNC talking to the serving gateway. So rather than SGW sending user traffic to the SGSN and SGSN sending packets to the RNC, we can directly send packets from serving gateway to the RNC. That's the directional architecture. Okay. And again, the benefit would be reduced cost because fewer SGSNs would be needed and also reduced latency. So the interface is S12 between the RNC and the serving gateway. Now we have chosen in LTE to use serving gateway as an anchor, 3GPP mobility anchor. So it means that if the user is in the LTE coverage area, so let's say here is E node P talking to the UE. So in that case, the traffic would be coming, let's say, from the outside world to PGW, to the serving gateway, to the eNode B, and then the UE. That is end-to-end flow of packets. On the other hand, if the user is in the UTRAN coverage area, then we would have the packets coming to the PGW, to the serving gateway. If there is no direct tunnel architecture, it would pass through SGSN and then RNC all the way to the UE. If we are using direct tunnel architecture, then the packets would be going from serving gateway directly to the RNC all the way to the UE. So serving gateway is the anchor. So regardless of what radio access technology the UE is using, we are able to use the same serving gateway. Serving gateway does not change. That's the user traffic. So hopefully the role of serving gateway is now clear. The PGW, it will allocate the IP address just like traditional LTE. Normally in UMTS, GSM allocates the IP address to the UE, but now there is no GSM. Operators can get rid of GSMs and replace those by PGWs. So now those packet data network gateways, PGWs, would be allocating the IP address to the UE, whether the UE is a legacy UE or a hybrid LTE UMTS UE. So PGW is giving the IP address to the device, and then SDW is the mobility anchor. So role of SDW and PGW should be clear. Then MME and SDSN link. Now what is happening there? This is basically used during handover for signaling purpose. When the user is going between two technologies, then for LTE UMTS handover, either direction, SGSN and MME would be exchanging signaling messages so that we can make sure the resources are available in the target system. Okay, so that's basically the interworking architecture with this kind of interfaces, S3, S4. S12 is optional. If you want to use direct tunnel architecture, you can use that. Another option is GNSGSM. Now we have got one question, so let's see if direct tunnel architecture is also possible with GPRS Edge. Yes, so you could forward packets with 2.5G technologies. Okay, then we have second option here, GNSGSN. Here, we do not touch existing SGSNs. Software is not upgraded. So it means it does not know that there is something called MME, there is something called serving gateway, and so on. So now, let's say you have that SGSN that has not been upgraded to understand release 8. If you physically connect that to the MME, it would think that it is talking to SGSN number 2. Let's say this is SGSN number 1. So it thinks that it is talking to another SGSN. So SGSN thinks of MME as another SGSN. Similarly, SGSN thinks of PGW as a GGSN. So SGSN thinks that it is connected to GGSN, but in reality, the operator has physically connected SGSN to the PGW. So in future, when a UE could be legacy UE or a hybrid LTE-UMTS UE, does not matter. When that UE tries to do PTP context activation to get an IP address to negotiate quality of service, so in that case, the PTP context activation request message will go to the SGSN, and now SGSN will work with PGW because it thinks that it is talking to GSM. So then the PGW allocates IP address to the UE, and then that is forwarded to the UE. So in this example, our SGSN is able to do PTP context activation using the help of PGW. It thinks that it is talking to GSM. Same way we use the other existing interface GN where another SGSN and SGSN1, they are exchanging handover signaling messages. So when the UE goes from LT to UMTS, UMTS to LT, then we will use that MME SGSN interface as if we were doing just intra UMTS, one UMTS area to another UMTS area kind of handover. That's what that link would be used for handover signaling. So in summary, we have two options. We can upgrade SGSN. It would be called S4 SGSN. It supports new interfaces. S4 is for user traffic, for example. We can use that for PTP context activation. S3 is for handover signaling between SGSN and MME. And GN SGSN, no impact on existing SGSN. They continue to support old interfaces. Okay. So in that case, MME looks like an SGSN and PGW appears like a GGSN. We already mentioned the interfaces. Basically, we have handover signaling on S3. We can do user traffic or some kind of signaling, PTP context activation type signaling on S4. Direct channel S12 will be useful. So those are the interfaces that we have. And SGSN can start using HSS through S60 to get authentication type information. Okay, now for smooth interworking between LTE and legacy networks, UMTS, GPRS, what kind of changes we need to make in the existing networks? That's the topic we would cover in the next few minutes. First of all, let's see what we need to do in 2.5G technologies. Now, we have two core networks, CS core and PS core, circuit switch and packet switch. The BSC in GSM GPRS edge controlling multiple base stations. And now, what do we need to do? At the minimum, we should at least enhance the BSC here. The reason for that is quite straightforward. If the UE is talking to the base station here, and it is in the border area, so maybe the adjacent geographic area, LTE is available. So we would like to know if there is LTE, and if there is LTE available in the nearby area, then how do we detect LTE system? Who is in the neighborhood? Which cells exist? So we need to know that. So that kind of information neighbor list for the LTE. We need to provide that to our radio network, and we will advertise the LTE neighbor related information in the system and information to creator. We have also possibility of sending measurement information related message to the UE when the UE is in the dedicated connected mode. So at the minimum, we should help the UE by providing the LTE neighbor information. Now, optionally, if you want even better performance, this is just to help detect LTE neighbors. But if you want to have smooth interworking, then you should support additional interfaces S4, S3, basically PDP context activation, and then we have signaling for handover, things like that. Direction architecture. A little bit later, I would talk about a very nice feature called network assisted cell change. So if we support that, then the handover would be faster from LTE to GPRS edge. And of course, for voice call, we could have support for circuit switch fallback. That would be applicable to GSM. So basically, at the minimum, we should upgrade the BSC. But if you do other things from this list, we'll get better performance. Similarly, if you have an existing UMTS network, HSP, HSPA plus network, then we should at least enhance the RNC software so that we can advertise new system information block number 19, and that would help the UE figure out which LTE cells to look for. And additionally, similar to what we just summarized for GPRS Edge, we have additional interfaces we can support for smooth interworking, in addition to support for circuit switch fallback. So basically, we have to upgrade at least the radio network. And if you support additional interfaces, you have even better performance. So we expect most of these features to be supported by operators in commercial networks. A brief review of how we identify the user and the network. So for example, we have device identification, International Mobile Equipment ID. That's for the device. So ESN would be part of that. So that's the hardware, basically. Then the subscriber is identified by IMSI, International Mobile Subscriber Identity. Then there is some kind of temporary identity for use in the next update. This would be discussed to the very end of the session. Basically, there is a feature, idle state signaling reduction. Idle state signaling reduction, and for that we will use this so-called TIN. We know that in LTE, whenever the UE has successfully performed HH operation, NME gives this GUTI to the UE. That is in the HH accept message. And the short form of that is used for paging. So short form of GUTI is ASTIMSI, and we will use that for paging. In UMTS world, GPRS world, packet themes is the identity we give to the user. Okay. Then from the network's perspective, we identify the operator, mobile country code, mobile network code, and then we have globally unique MME identity. That's how we identify the MME. We have in tracking areas. That's how we know where the user is when the user is in the idle mode. So we can send a page message to all the E node Bs in a given tracking area. In the UMTS world, we have routing area, we have location area, and so on. Location area for the circuit switch system, routing area for the packet switch system, SGSM. Okay, time for me to ask you a couple of questions. So we'll give you a couple of minutes to think about this poll question. Now for the choice number 2, we have not talked much about that in the series because GTP is the main protocol that we have seen deployed by operators. So it might be slightly unfair. So do not choose that. There are two options as far as the standard is concerned. On the S5 we have GTP and we have proxy mobile IP. Okay, GTP and proxy mobile IP. So standard supports both protocols on S5, S8. However, in practice, operators, AT&T, Verizon, etc., they have chosen GTP. So GTP is the one we have mentioned typically during the series. Okay. So that's probably if we have covered it maybe session 1 or the previous series. So don't worry about choice number 2. Focus on other aspects, other options that we have covered here this morning. Okay, 1 more minute. Easy to change your selection. If you click on another button, you will be okay. Okay, let's share the results. Okay, so the first one, S3 connects MME SGSN, no problem. As I said, S5 we may have GTP or proxy mobile IP, even though we have seen only GTP in practice, so no problem for that. Okay, S4 is a daytown interface. Yeah, actually that is not correct, right? So that is the answer. That S4, let's go back to our S4. See, S4, that is between the serving gateway and the SGSM. So what can we do with that? Here, we can forward the packets, SCW and SGSM. So the user traffic can go over that. And if we have a user trying to do PDB context activation, we also have signaling messages going over that. So we have signaling and the traffic both flowing through S4. Okay, let's go back to our question. S12, there is only traffic, so that is correct. S12 is for direct tunnel architecture, and the only thing we are sending there is traffic, right, between RNC and the serving gateway. And of course S3, that's between the SGSN and MME, only signaling, no traffic. So that is correct. S3 is signaling only interface. Thank you for participating in the poll question. One more question. So in which case SGSN will need to pick some MME. So think about the use of interface. That S3, how do we use that interface? I will give you a couple of minutes, 2-3 minutes to think about this. So again, my hint is we have S3 between SGSN and MME. So what do we do using S3? That will give you the answer to the question. Use of S3. Okay, let's see what we have. Okay, so more than 60% got it right. So S3 is for handover signaling. So SGSN has to choose MME when the UE goes from UMTS to LTE. Because then currently UE is with the UMTS. If it is going to LTE, we need to exchange handover signal with some MME. So at that point in time, our SGSN has to pick which MME it should talk to exchange handover signaling messages. When we are going from LTE to UMTS, then MME would have to pick SGSN, not the other way. And when we have the UE attaching to EUTRAN, SGSN has no role to play. Okay. Also, when UE attaches using UMTS network, again, SGSN would directly work with serving gateway for PDP context, etc. So no role for MME in that case either. Thank you for participating in the poll. So now, let's talk about PDP context, activation of that. Okay, now we will cover a variety of scenarios, and if you have a UE, let's say currently powering up in the UMTS only area, it is an example of UMTS access. The UE is contacting the network through UMTS technology. So we will talk about that scenario. So in that case, our serving gateway is the mobility anchor. So for 3GPP mobility, serving gateway is the mobility anchor. 3GPP mobility means going from LTE to UMTS, LTE to GPRS and vice versa. So that's UMTS access. Now the UE keeps driving and enters LTE coverage area. So then you would have to do the handover from UMTS to LTE. So basically when the UE detects a stronger LTE cell, then we will have to do handover. So that is another scenario. Now let's say the UE keeps moving. Now we go outside the LTE coverage area. So then we have to do the handover from LTE to UMTS. Okay. So we would talk about all these various scenarios shown here. Okay. Now, PDP context. In LTE, we use the term EPS bearer, Evolved Packet System Bearer. And in legacy technologies, UMTS, we use the term PDP context. So they are equivalent. So PDP context is analogous to EPS bearer of LTE. So when we have a UE that has a PDP context activated, then it has a logical link all the way to the GSM if it's a legacy system. So UE and the base station RNC via SGSM and GSM. So that would be your end-to-end PDP context in the case of legacy system. Now, in the context of LTE, we do not need GSM. So in that case, PGW is the anchor for IP address. So it means that we would be taking care of GSM functions at the PGW. So now the PDP context is between UE, Node BRNC, SGSM, serving gateway, and then the PGW. So that is your PDP context when we have started using the EPC. Now, right now, SGSM is involved in the data transfer through PDP context. Of course, if you have direct architecture, then no need to worry about SGSM. Then we have the connectivity between UE, node B, RNC, and then serving gateway, PGW. No role for SGSN in case of directional architecture. So that is basically what we have in terms of PDB context when we have as for SGSN. On the other hand, let's say we do not upgrade SGSN. So then SGSN would be talking to the PGW, assuming that it is talking to some GSM, because PGW appears as a GSM to SGSM. So SGSM thinks it is talking to GSM. So in that case, if we have a UE in UMTS coverage area trying to do PDB context activation, it would be talking through the node B, RNC, SGSN, and then directly the PGW, because we have SGSN, GGSN type connectivity here. This is the GN interface. So in that case, we do not have a role for the serving gateway in terms of connectivity between SGSN and PGW. So now that is basically the PDB context in the legacy system and PDB context when we start using the EPC, Evolved Packet Core, Serving Gateway, PGW, and so on. So the links that constitute our PDB context, they are different, okay, in different scenarios. Okay, now let's talk about the call flow, an overview of what kind of signaling messages we exchange to set up a PDB context. So here is the basic scenario where our UE has done power up in UMTS only area. So there is no LTE available in that coverage area. Only UTRAN is available. So we have done, let's say, location update or registration, and now we are ready to do some packet data transfer. Before we can do packet data transfer, we need to set up a PDB context. So that's what we are trying to do here. Okay. The UE sends a PDB context activation request message indicating the requested quality of service and access point name, let's say AT&T.com, and request for an IP address. So that's all inside the PDB context activation message. The message finds its way from UE node B to the RNC, RNC to the SGSN. This is signaling. So signaling, SGSN takes care of signaling. So SGSN receives the activation request message for a PDB context. Now this is an S for SGSN. So we have upgraded that to understand LTE. So now it will talk to the serving gateway, okay, because that's that interface. So here is an example where S4 is used for signaling exchange. So the SGSN requires the SGW to create a session look at the message name, create session request. So this is GTP version 2 control plane message, and this is LTE protocol. Right? We have enhanced the GTP GPS steering protocol to understand LTE. So that is version 2 for the control plane. So on S4 for the control plane, we use GTP version 2. So create session request is going for that specific UE with certain IMSI. PGW address, so that's this PGW here. So basically, let's say AT&T.com, who is responsible for that. Typically some GSM, but now we are using EPC, so some PGW is in charge of AT&T.com, APN. So the PGW is now identified by GSM, and serving gateway will talk to that specific PGW and make a request to create a new session. And now we tell the PGW that, okay, I need to set up a bearer, and please give the IP address for that bearer. Now, the PGW reserves an IP address for the UE, and that will find its way to the SCSN, create bearer response containing that IP address that PGW just allocated. And now the SCSN accepts the PDB context activation message, and it includes the IP address that PGW allocated to the UE and whatever QS that we have negotiated. Even though in the message we call it negotiated QS, there is no real negotiation. Poor UE has to accept whatever QS the network is allocating. So there is no real negotiation, but just to make the UE feel good, we have the term negotiated QS. But it's decided by the network on its own. UE can make a request for some QS. Let's say I want to get 100 kilobits per second or 300 kilobits per second maximum data rate. So you can make a request in the PTP context request message, but it is the network that is in charge. So network makes the decision about data rates and things like that. So the message basically will find its way to the UE. We have got a question. If we have DNS, how the APN would be PGW selection? So basically what would happen is if you want to keep the things dynamic, maybe you want to add some PGWs, remove some PGWs from service for maintenance or whatever reasons, then what you can do is the following. The SDSN, for example, can ask DNS that I want to talk to some PGW who is in charge of AT&T.com. So that message goes to some DNS server. And then DNS server says, okay, PGW with IP address A, B, C, D. Talk to that PGW. So in this case, the DNS server has helped us figure out which of the PGWs we should communicate with. So that's one way. We can have a database in the SGSN, that is another way. But typically, if you want to keep things dynamic, then DNS server is desirable in that case. Thank you for your question. So basically, the UE made a request to activate the PDB context, and now we use this S4 interface. And in that case, SDW is helping us create a session for the UE. PGW is the one that acts like GSM and gives IP address to the UE. So that is the key here. The serving gateway is our anchor. We use serving gateway for signaling in this case. So even though our UE may be a pure legacy UE, meaning it does not support LTE, even in that case, our UE gets an IP address from PGW. UE does not know that we have started using PGW, we have started using serving gateway. UE does not need to know that. From the UE's perspective, it talks to some SGSN, and that's it. It sends the PDB context type messages to the SGSN, and SGSN will reply back to the UE. So within the network, we can get rid of GSM. We can add SGWs, etc. UE does not need to know that. There is no impact on the UE. Maybe legacy UE, maybe a brand new LTE UMTS UE. Both UEs, when they are in the UMTS coverage area and there is no LTE available, as part of the PDB context activation, we have already started using the EPC. We have used SGW here, we have used PGW, and so on. So the idea here is that we will start using the LTE core network more and more as time passes by, so that we have to maintain a single network. So we can start removing GSMs, for example. Okay, now the quality of service. Okay, let's. We are almost an hour. Okay, maybe we can discuss this and then we'll have a break. Okay. LTE. We have EPS bearer and GPRS, UMTS. We have PDB context. How do we identify the EPS bearer? We have some bearer numbers, like 4-bit number. So ideally we can have 16 bearers, but some are reserved. So 11 bearers are supported right now in release 8. Now bearer would be mapped onto the PDB context NSAPI. That's the number we use for PDB context. What we call default EPS bearer in LT is mapped onto a primary PDB context. The dedicated EPS bearer would be mapped onto a secondary PDB context. Let me ask you a question. So we have default EPS bearer, we have dedicated EPS bearer. So which of the two gives the user always on experience? Is it default or dedicated? Which gives the user always on experience? Default or dedicated? Okay, we have got some answers. Excellent. Very good. So default, absolutely correct. So default EPS bearer gives the user always on experience. On the other hand, if you are trying to control quality of service stringently, then you should be going after dedicated EPS bearer. So default EPS bearer would be mapped onto primary PDB context. And if you recall from basic UMTS, anytime you want to have same IP address but different QoS for your services, for your applications, then we need secondary PDB context. So primary PDB context would be good enough for email, web browsing, for example. But if you want to do video streaming or something like that, then it needs a different quality of service level. And for that, we would have a secondary PDB context. Same idea. The default dedicated, similarly primary and secondary PDB context. So every bearer's QoS in the LTE world has to be mapped onto some UMTS quality of service. So let's take an example. For example, in UMTS, for a voice call, we have so-called conversational class. that would be equivalent to QCI number 1, quality of service class indicator 1. Then streaming would be equivalent to QCI 4, interactive and background. Okay, so those are the equivalent numbers. And we have the maximum bit rate in the UMTS that would be equivalent to access point name specific aggregate maximum bit rate. When you have guarantees of data rate, guaranteed bit rate, and maximum bit rate, that would be equivalent to GBR, MBR in LTE world, or whatever we call transfer delay, equivalent to that in LTE is the packet delay budget. So for example, we have 100 millisecond packet delay budget in case of QCI 1. So that is between the UE and the PGW. Okay, one way end-to-end delay within the network. And the error rate in LTE here is equivalent to the service data unit error ratio in the UMTS world. So we have figured out this kind of mapping so that when the UE goes from one technology to another technology, then we will be able to do the mapping. We have one question. Does the default bearer always have lowest QoS? Yes, correct. The default EPS bearer has QCI 8 or 9. Yes, so it has the lowest quality of service. There is no data rate guarantee. And the delay is the longest, I think 300 milliseconds, if I remember correctly. So yes, it has lowest level of quality of service. Absolutely. Okay, time for a poll question, and then we will have a short break. So I will give you a couple of minutes for you to participate in the poll. Thirty seconds remaining. Okay, let's share the results. Okay, almost 75% got it, right? So PGW, that's the answer, PGW. PGW gives IP address, whether it's a legacy UE or hybrid LTE-UMTS UE. PGW gives IP address. So whether the user is in the LTE coverage area or UMTS, GPRS, edge, it does not matter. Once we have given an IP address to the UE, that is valid, regardless of the technology the UE is using. And that is the beauty of IP mobility. Same IP address in LTE, in UMTS, GPS edge. So it does not matter what radio access technology the user is using. Okay, we have a question coming on the live meeting. Let's take care of that one. If not pre-release it, QCI. Oh, same name. Oh, actually, this is all the way up to, let's say, release 99. Right? We have release 99 that has defined those 4 levels of QoS. So yeah, it doesn't matter. Could be release 99 or 4, 5, 6, 7. Okay, does not matter. It started from release 99, the first release of UMTS. So it's still valid, same name, same approach. Thank you for your question. So let's have a short break, and I will give you about 12 minutes. So welcome back. Any questions through the audio bridge? I will wait for 10 more seconds. Star 7 unmute, star 6 mute. Okay, let's move forward. So we talked about the UE accessing the network via UTRAN. So the UE did PTP context activation, and in that case, when we have S4 SGSM, it works with serving gateway. Serving gateway works with the PGW so that we can take care of PTP context activation. So PTP context has been established. So the packet transfer can now occur between UE node B RNC, RNC SGSN, SGSN serving gateway PGW. If we use direct tunnel architecture, then the packet transfer is via UE node B RNC and then directly serving gateway. So we bypass SGSN in case of direct tunnel. So that is UMTS access, and the UE is doing packet data transfer using UMTS radio access technology, UTRAN. Now, the UE enters LTE coverage area. So earlier we had the UE with UTRAN, but now the UE comes into the region where LTE is deployed. So now, since LTE is available, then we should do the handover to LTE so that we can get higher data rates from LTE radio network, EU-TRAN. That's what we would discuss next. Okay. So currently, in the UMTS coverage area, the packets from the outside world, they are arriving at the PGW. Serving gateway is the mobility anchor, 3GPP mobility anchor. Since we are in the UMTS coverage area, the serving gateway forwards the packets to the SGSN or directly to the RNC. And finally, RNC through node B, packets are reaching the UE. That is the traffic path. Now, the UE has detected strong UMTS cells, one or more cells, and it sends measurement report to the RNC. Okay, let me talk about that in more details. We have a better view of what is happening on the air interface. So currently U is with the UMTS system, and the RNC would send a message, measurement control message to the UE. And as part of that, we can provide information on how to detect EU trans cells, like what kind of frequencies we have and so on. And we can configure the UE with measurement events. Okay. And I will give you some examples a little later. An example in brief is the following, where LTE cell becomes better than UMTS cell. So in that case, some event would occur, and when that event occurs, the UE sends a measurement report message. In UMTS, RNC implements the handover algorithm. So the handover algorithm in the RNC processes the measurement report. So it may say that RSRP, reference signal received power, for physical layer cell ID number 10, let's say this is LTE, is perhaps minus 85 dBm. However, ECR and not for a UMTS primary scrambling code is, let's say, quite weak. Primary scrambling code 100, let's say minus 14 dB. So we have very weak UMTS measurement, quite good LTE measurement. So the RNC decides that yes, it is time for the UE to go to LTE, because LTE is able to provide a better quality signal. So that is the status. The RNC has made the handover decision based on the measurement report provided by the user equipment. The RNC tells the SGSN that we need to relocate the user to LTE, and it would identify which E node B the handover should be made to. So that's the identity of the E node B. And we have so-called container, transparent container, that RNC is sending to the E node B. Basically, this is nothing but handover request. We have to get radio resources for that handover. So information about the existing PDB context is given in that container, so that E node B in LTE can check, do I have adequate radio resources, so-called resource blocks, to be able to support that UE, because the UE has already several existing PDB context. So that is basically the container. The reason we call it transparent container is that only the destination, which is E node B in our example, only the destination would really go inside the container and process that whatever is inside that container. The other nodes, they just transparently let that container pass through. So in this example, SJSN passes that to the serving gateways. Serving gateway passes that to the, let's say we are going to use the S3 interface. So it is going to MME. Okay. So that is the example where we are letting the container pass through the system. only when that container reaches the E node B, the E node B will look inside the container. And we also have to tell the target system, right, the existing information about the bearers, what APNs we have connected to, what IP addresses are already allocated to the UE, and information about the authentication. The reason for that is that we have already done the authentication in the UMTS system. So we want to avoid doing the authentication in LTE. So we are doing some kind of mapping. We are generating some authentication vector for LTE so that MME does not have to do the authentication. So that is the idea behind that. And the E node B that should be receiving the container that is identified here by RNC. Identity of the subscriber is included, that is INVI. So basically, we are using the S3 interface to help us do handover signaling message exchange. So handover signaling. Okay. So SGSN and MME. In between them, we have S3 interface. Now, the MME will contact the E node B identified in the handover request message. This relocation request message, and it will include that container. We also would include information about the bearer that we need to set up and the quality of service. Okay, because SGSN has UMTS, QoS information for PDB context. But as I mentioned earlier, when the user goes to LTE, we have LTE quality of service. So we have to do the mapping. So MME will help us do the mapping between the PDB context from the UMTS perspective and EPS bearer from the LTE perspective. So that kind of mapping for QoS is done by MME. That is important point here. And information about the GTP channels that we have for that UE that is included also. Now the E node B looks at the QoS that is currently requested for that UE. At EPS bearer number 1, we need to have certain megabits per second maximum data rate. Another EPS bearer, we have guarantee of 10 kilobits per second or something like that. So basically, the E node B will do the call admission control, make sure that it has adequate radio resources. So let's assume that we are not too busy, we have adequate resources available in the E node B. Then we would send the acknowledgement message, and whatever bearers we were able to admit, we identify those. And sometimes if the E node B is running out of resources, then we have to block, we have to reject some bearers. So that list is also included. The MME now responds to the relocation request. So it got relocation request in step 3, and the response to that is relocation response. And inside that we have the container that is from E node B to the RNC. So basically here we are including information such that the UE is able to contact LTE when it is done with the handover. So radio resources in the target system, in this case LTE, they are included in the container, and we would provide the identity of the serving gateway E node B from the IP addressing perspective. So we would include IP address of either the serving gateway or the E node B, and the channel endpoint ID. Because what would we need to do is we would like to do packet forwarding. Okay. So if you want to do packet forwarding, then in UMTS, the data is buffered at the RNC. In the LTE system, the data is buffered at the E node B. Okay. So if you want to forward the packets, then we have to give the IP address of destination. So if we are able to directly do packet forwarding from RNC to the E node B, then we would need E node B's IP address and the GTP tunnel endpoint ID. So this is a GTP tunnel. So we need to give that tunnel endpoint ID. So that's one way. This is an example of direct packet forwarding. On the other hand, we may have to pass through serving gateway. So in that case, RNC needs to know the SGW IP address and the tunnel endpoint ID for the SGW. So this would be an example of indirect packet forwarding. Now we could have direct, no, let me not use that term. We can have RNC forwarding the packets to the serving gateway, which will find its way to the E node B. Or we can just use help of SGSN, and SGSN can then forward packets to the serving gateway to the E node B. That is another option for indirect packet forwarding. Okay. Basically, it will pass through serving gateway, either directly RNC serving gateway E node B or via SGSN. That is the direct tunnel architecture. In direct tunnel architecture, we can bypass SGSN for user traffic. Okay, so if you look at this picture here, RNC forwarding the packets to the SDW, and there is no SGSN involved. That would be an example of direct tunnel architecture, but it is still indirect forwarding because we are not forwarding packets directly RNC to the destination node. We are using an intermediate node such as serving gateway to help us forward the packets all the way to the destination. Okay, that is the idea. Okay. So basically, what we have done so far is we have reserved the radio resources in the target system, and we have informed the source system that the IP address for packet forwarding and the tunnel endpoint ID for the packet forwarding are as specified in message number 7, in step 7. Okay. So now the source system, UMTS in our example, knows that target is ready. So we will have to send the handover command. So the RNC here would get the relocation command from SGSN, including the container. That container is processed by RNC. RNC can put that information in the handover from Utran command, RRC message. And here we would indicate the information so LTE can be accessed by the UE because we have reserved the resources in the LTE system. Now, up to this point, the data transfer is ongoing between the UE and UMTS system via and using the help of EPC. We have one question. Before handing over from UMTS to LTE, UE did not have a default bearer, right? Correct. See, when we were in the UMTS coverage area, then we did PDB contacts activation. So we had primary PDB contacts, maybe secondary PDB contacts, and so on. So we did not have default bearer. That is correct. But now it will be established default bearer, maybe some dedicated EPS bearers. They would be established now as part of the handover. That is correct. Remember we said the default bearer, let me quickly go there. Default bearer would be mapped onto some primary PDB contacts, dedicated mapped to some secondary PDB contacts, and so on. And the quality of service, we have to do mapping. So MME will help us do this kind of mapping when we go from UMTS to LT. So yes, you are right. During the handover process, we are setting up those bearers. Absolutely correct. We would have to set up those. Okay, so going from UMTS to LT, we have made the resource reservation in the target system LT, and the handover command is sent. That go to LT, go to this cell, let's say cell number whatever, PCI number 10. So the UE will then contact LTE system. But until that message handover command is received, the data transfer is ongoing between the UE and the UMTS system. Now we have interruption. So from this point onwards, we have some interruption until we have successful communication with the LTE radio network, E node B more specifically. So that would be the delay. Okay, so if you want to figure out how your delay is it too little, too short, or we have long delay, then we would have to measure that so that we can quantify the handover performance. Now, what kind of information in the container? So basically, I will give you one example. So RNC from UMTS to LT handover, we have to make a request for radio resources. So we need to know what kind of data rate guarantees we may have, what kind of maximum data rate promises we have made. We need to identify the LTE cell, right? So one E node B may be controlling 3 LTE cells, physical layer, cell ID 10, 11, 12. So then we need to identify what cell we are interested in, because there is no soft handover in LTE, there is hard handover. UE can only talk to a single cell at any time. So we need to identify which LTE cell we are interested in for that UE. So this kind of radio resources related information is inside the container going from RNC to the E node B. Now when the E node B is making the decision about what bearers to admit and things like that, it has already looked at the resource availability, and then it will inform the source system, RNC, in the container that, okay, in cell number 10, PCI number 10, I have reserved resources and I have admitted these kind of bearers with this kind of quality of service. So that kind of information is in the container. And if you are interested in getting more details, look at the S1 application protocol, S1 AP, 36413, 423, something like that, and you will get a lot of fields inside the containers. Okay, and thanks for your question. Very good question. Okay, so up to step 9, the data transfer is ongoing with the UMTS system, but now the UE has contacted the LTE cell, specific cell in a given E node B, and then it sends a message. Hand over to EU trans complete. That is the RRC message that we are sending. So basically, we have the RRC connection established as part of the access, and since we have the RRC connection established, we are able to send this handover to EU and complete RRC message. So step number 10, once the E node B has got the handover to EU and complete RRC message, we have an interface operational between the UE and E node B. So now we will tell the source system that in the target we have successfully established contact with the UE. We need to do that because in the UMTS source system there are still resources reserved for the UE, so we need to release those resources. So we need a way to contact the source system, and that's initiated here. E node B sending S1 application protocol message, handover notify, that is over the S1MM interface here. So we are notifying, we are telling the MME that handover is completed from the air interface perspective. MME then tells the SGSM on S3 interface that relocation has been completed. Now, we got one question in the Q&A box. What is this ISR? Idle state signaling reduction. Idle state signaling reduction. Do not worry about that now. We will talk about that toward the end of the session. But basically, what ISR is it reduces the amount of signaling that the UE has to do when it goes back and forth between LTE and UMTS technology. So normally what happens if you go from LTE to UMTS, it has to do that routing area update. If it goes from LTE to UMTS, going into UMTS, you have to do routing area update. So if the UE just goes back and forth between two technologies, then we have a lot of processing power needed. You have a lot of battery power consumed. Network has to do a lot of processing. So if you want to avoid all that, then we have this feature called ISR, where the UE does not need to keep doing the tracking area and the routing area updates if it goes between two technologies back and forth. That is the ISR. And we'll talk more about that toward the end of the session. Okay. But we could set that to true. So when the UE enters idle mode, then we can save some processing power and battery power. Okay. There was one more question related to, okay, before the handover is complete, who stores data? Who stores data? Okay, so remember we have UMTS RNC buffering the data. So in UMTS RNC buffers the data. LTE E node B buffers the data. So when we have these packet forwarding tunnels, BGP tunnels established effectively between RNC and the E node B, then until the handover is completed, until we start talking to E node B, the E node B is buffering the packets coming from the RNC. So it is RNC is forwarding the packets. So packets are initially buffered at the RNC because that is the current source system. So packets are going PGW to the serving gateway to the RNC directly or through the SGSN if there is no direct channel architecture. So now the packets are being buffered at the RNC, and since we have packet forwarding in place, eNode B is buffering the packets. So until the handover is fully completed, eNode B is buffering the packets. Okay. Any other question? Just type away. Basically, if I do not get any follow-up question, I would assume you are doing just fine. So please feel free to ask additional questions for clarity or more details. Okay. So the target LTE has informed the source UMTS system. The relocation has been completed and the acknowledgement goes from SGSN to the MME. Now, we need to switch the bearers. Remember, what is happening is so far we are having the link so from CNN the packets are coming to the PGW, SGW to the RNC, right? So right now our SGW is forwarding the packets to the RNC directly or via SGSN. Now we need to tell SGW, do not forward the packets to UMTS because our handover is complete. So SGW should be forwarding packets to the eNode B now. So that's what MM is saying. So MM is telling the serving gateway, modify your bearer, basically your tunnel endpoint ID. Let's say we have TEIDX, okay, TEIDA on the SGW side. So now we need to change the endpoint. Instead of X, we need to have Y. So that is here, tunnel endpoint ID Y. So we say use tunnel endpoint ID Y for eNode B. So do not use the tunnel point X because that is for the UMTS system. U is already in the LTE coverage area. So we provide that information here in the modify bearer request. And now whenever a packet comes from the PGW, it would be forwarded to the eNode B using that newly established GTP tunnel. So we no longer send the packets to the UMTS system now. So that is the modify bearer request response. So PGW the serving gateway to the eNode B. That is your S1 user plane. Since we have gone into LTE area, we have a change in the UE location. It's no longer in some routing area of UMTS, it is in some tracking area of LTE. So the UE would be doing the tracking area update. We would have to release the resources within the UMTS system. See, SGSN already has sent the acknowledgement that handover is completed. And I know that. So now, any point in future, we can start releasing the UMTS resources. So we get rid of the RRC, the radio bearers, access bearer, and then the S4 GTP tunnel. So we release all the existing UMTS connectivity. Okay, we have a couple of questions. So UE will be in a compressed mode until handover is complete. UE will be in the compressed mode. Okay, so let's look at that. See, we have sent the handover command, right? So up to step 9, we have UE on the UMTS system. And after that, there is no compressed mode because the UE is no longer on UMTS. So we could potentially have UE in the compressed mode of UMTS until step number 9. Beyond that, no need to worry because UE is no longer on the UMTS air interface. Okay, then there is a suggestion. Can you show cursor and... Oh, yeah. Actually, I have been trying to use this pointer, but for some reason... yeah, sometimes, yeah, now it shows up. Okay, sometimes it does not show up. Okay, sure. I will try to point to the cursor, point to a specific node. Okay. Okay. Thanks for your feedback. I did try, but a couple of times it didn't show up. Okay. Then there is another question. Step 14, modify will come with the new TID. Would it be also tear down the old TID with UMTS? Oh, yes, yes, yes. So when we switch the bearer path, so when we have this modify bearer request, let's use that pointer. Yeah, hopefully it will show up now. Yes. So in step number 14, when we have modify bearer request response, with the serving gateway, then the serving gateway knows that I'm switching the path. So then at that time, the old GTP tunnel with SGSL, for example, would be released. That is correct. So that PEID is now available for some other bearer, some other user, and so on. That is correct. Absolutely. So we'll tab that down. Yes, yes. Okay. Very good. Thank you for your questions. Time for me to ask you a question. So I will give you a couple of minutes to work on this one. Thirty more seconds. Okay. So it is true. we never talked about PGW in the signaling. So if you look at the signaling here, right, we never have communication between the serving gateway and the PGW because that S5 connectivity, right, SGW PGW connectivity, it is not affected. PGWZ doesn't have to worry. As far as PGW is concerned, it has some GTP tunnels with the serving gateway, and if the serving gateway does not change during handover, then there is no impact on the PGW. If your serving gateway changes, that's a different story. Then we have to inform PGW that, oh, now we have a new serving gateway. So the other end of the GTP tunnel, the SGW side, would be changing. So unless there is a change in the serving gateway, no need to worry about interactions between the serving gateway and the PGW. Okay, so that SGW PGW, no impact as long as same serving gateway is used before and after handover. We have a question on the resources. If the E node B did not have resources, do we deny the handover request? And is there a waiting period? So basically, let's go to See, the E node B has received in step 4 handover request, and it has all the QoS requirements, right? QoS requirements. Now, if the E node B in step 5 does not have radio resources, then in the response it would reject the request for handover. Okay. So yeah, that would occur here in step number 6. And we would tell some kind of reason that we are running out of resources, something like that. Oh, looks like we got some more questions. Let's address those. And thank you for your questions. If UE moves to a different time zone, then PGW needs to be informed of the change even if serving gateway does not change. No, I'm not personally aware of this time zone stuff. Let me try to find that information. But if you are confident about that, then yeah, that's possible. That PGW may have to be informed if we have change in the time zone. Okay, so I will take your word for it. There is another comment, but the PGW will need to be told to send traffic to the E node B. Oh, not really. See, the PGW sends traffic to whom? Serving gateway. Serving gateway sends the traffic to UMTS or E node B, whatever. So PGW does not know about the E node B. It doesn't worry about E node B. It has no connectivity with any E node B. It doesn't have to worry about that. The only thing PGW worries about is serving gateway. Okay. If we have S4 SGSN, if we are talking about GN SGSN, the old legacy SGSN, then PGW acts like GSN. It talks to SGSN directly. So PGW worries about either the serving gateway or SGSN. It does not worry about E node B. It has no connectivity. There is no link, no interface between PGW and the eNode B. Now, there are a couple of other questions. Okay, so during handover completion, UMTS to LTE, okay, you will get IP assigned by PGW, so it needs more. Oh, you are talking about IP address. Okay, see, in 3GPP mobility, okay, our serving gateway is the anchor, so our IP address has not changed. So whatever we got when we were in the UMTS world, we did PDB context activation. So PGW gave us the IP address. Okay, so that will never change. So for the purpose of that, during the handover itself, we are talking about only handover signaling, right? So during the handover signaling itself, PGW does not have any active role. But yes, before we did the handover, yes, then PGW was involved because it gave the IP address. Okay, so hopefully this is more clear now. Another follow-up question: if the eNode B has no resources available, will the MME decide which other eNode B to do handover to? Actually, that would be little implementation specific, because what is happening here, let's go to the very first page here for handover. See, the RNC has got this measurement report, okay, and based on that, it has chosen a specific eNode B. Now, if in the measurement report, let's say there are two LTE cells, one LTE cell controlled by one eNode B, another LTE cell controlled by another eNode B, then it would be up to the RNC to make another request with another eNode B identity. So that is possible, but that would be, I think, implementation specific. So MME doesn't decide that. RNC instructs MME that, oh, I have this eNode B, and please talk to that specific eNode B for radio resources. So if someone had to choose a different eNode B, it would have to be, in my opinion, RNC, because RNC knows about the measurement reports, and RNC knows about the eNode B is in charge of those LTE cells. So if this does not make sense, just let me know. And again, thank you for your questions. Okay. So we talked about handover from UMTS to LTE. Let's see what we have next. The other scenario. So now we go from LTE to UMTS. Test the focus next. And again, we are assuming S4 SGSN, meaning SGSN has been upgraded to understand LTE. Okay. So currently, the UE is with the LTE system. So packets from the outside world, they arrive at the PGW to the serving gateway over S5, serving gateway to the eNode B over the radio bearer to the UE. That is the end-to-end path followed by user traffic, IP packets. Now, the UE is sending the information about the radio environment. So in the LTE, we have a famous message. Okay, maybe I should write in the journal so you have more space to look at. Okay, so now we are talking about LTE to UMTS handover. So in preparation for that, our eNote B has in the past sent RRC connection reconfiguration message. So if I have not told you already in a previous session, if you want to know a single message, RRC message in the LTE, this is the message. It is used to do many things. You can use the message to set up a data radio bearer, send this message to ask UE to make certain measurements, send the same message to send a handover command to the UE. Lot of things can be done using the same message, RRC connection reconfiguration. Okay. Very important message. Okay. So as part of the RRC connection reconfiguration, we can instruct UE what to measure, at what technology. So we will say UMTS. We can give information about the neighbors, issue or not, issue or not for UMTS, and when to report the measurements. So we will basically configure the UE with this kind of stuff. There are some events. We'll talk about that a little later, but a simple example is UMTS neighbor is becoming better than current LTE cell. Then some event occurs and the UE sends a measurement report. In the measurement report, we would say, okay, is your and not for primary scrambling code is -8 dB. RSRP is very weak for the currently serving cell in LTE. So basically, our LTE is becoming poor quality and UMTS is able to give better quality signal. So in that case, the eNote B makes the handover decision. Handover algorithm is implemented inside the eNote B. So eNote B decides that UE should be allowed to go to UMTS now. Maybe it is leaving the LTE coverage area, no more LTE to be found. So that's the stage. So measurement report is now received in step 1 by eNote B. eNote B has made the handover decision in step number 2. Now eNote B tells the MME that we need to do the handover. And oh, sorry, we have a typo. We need to figure out which RNC the MME should talk to. Due to the measurement report, we know that this is the primary scrambling code of UMTS and that cell is controlled by a specific RNC. So that's the identity of the RNC. In the request for handover, basically we have certain EPS bearers and what kind of data we have promised, things like that. So we have information on the requested resources in the eNote B2 RNC transparent container. MME then talks to this this specific RNC. There's the relocation request, and we identify the user. We provide the container, and to avoid the authentication in the UMTS system, we do the mapping between LTE authentication, UMTS authentication vectors, and that's the authentication vector created here. the existing information about the bearers. So we tell the target system, UMTS, information about the bearers, and what kind of EPNs we are connected to, what IP addresses we have allocated, and so on. So that information goes to the SGS. Let's see if we have to address questions now, or we can do later. One question, this handover is for data. And would it be same for voice if we have voice or LTE? Absolutely correct. So what we are showing is for packet data handover. So when voice or LTE is there, very, very simple. Voice or LTE, just one additional EPS bearer with QCI number 1, with data rate guarantee, GBR, perhaps 12.2 kbps. So yes, same process, even with voice over LTE. Absolutely correct. So as long as we support voice or IP in the LTE world and the UMTS world, we are okay. So hopefully the traditional UMTS systems would also start supporting packet switch voice over IP for a given user. So we can do that at that time. Okay. Otherwise, we have to do the packet switch handover and the separate handover from voice or IP into a CS call. Okay. So in that case, we would have to use something like SRVCC, single radio voice call continuity. So in LTE we were using voice or IP, and then if we have to go to CS, then we have to do the transition. So it depends on what is available in future. But in general, yes, same process. If it is voice or IP in LTE, voice or IP in UMTS world, then yeah, it's the same process. Voice or IP is just one additional EPS bearer. Okay, so that's the relocation request to relocate UE from LTE to UMTS. Now the SGSN has to work with its own RNC. So it tells the RNC, here is the request for relocation, and this is the container coming from LTE. Now, from the LTE side, we have the information on bearers that we have, and we have QCIs, etc. for that. And UMTS, we have to work with radio access bearer. Okay. So we will have a PDB context with QS information over the radio interface. It is the radio access bearer. So we have to have QS related to the EPS bearers, and the RNC will look at the QS, which is part of the radio access bearer information, to see if we have enough power available, enough number of OVSF codes available to support that UE's bearers. Assuming that we have sufficient radio resources available, the RNC sends positive acknowledgement to the relocation request. The SGSN sends forward relocation response, which is answer to the step number 4 request message. And again, we can have packet forwarding. So in that case, E node B has packets being buffered, and in the UMTS world, the RNC has to have packets buffered. So we need to have a tunnel in that case. It is optional, but standard supports it. So we have the tunnel here. Somehow we need to get the tunnel. So we can go via serving gateway. So that is the serving gateway tunnel endpoint ID. Okay, so it would be going E node B to the serving gateway, and if you have astral interface, it can directly go to the RNC, or if there is no direct tunnel, no problem, we can go via SGS. Basically, we have to find the overall connectivity. We need to get that established for forwarding the packets. The handover command is now sent to the E node B because the resources are already reserved in the UMTS target system. RNC to the E node B container. So basically this would contain information on the radio resources, how to contact the UMTS system, and information about the packet forwarding. That is also given. Now, E node B over the air interface sends the handover command. So it's mobility from EUTRA command. So there's the RRC message that specifies to the UE which UMTS cell to contact, and up to that point the data transfer is ongoing, no problem. Once the UE receives the mobility from EUTRA command, it stops looking at the LTE air interface. It disappears from LTE and tries to communicate with the UMTS radio network, EUTRA. So until the handover is completed, we will have some interruption. So this is the handover interruption. Until we have successful communication over the air interface between the UE and RNC, we have interruption. No packet transfer during that time. However, we still have packet forwarding. If you want to ensure zero packet loss, then that's what we have. So PGW, forwarding packets to the serving gateway to the E node B. E node B is buffering the packets, but now we have to forward the packets. So the packets are going back E node B to the serving gateway to the SGSM. Remember, that is our S4. So we can forward the packets. SGSM forwards the packets to the RNC. So basically our packets are now being buffered at the RNC. So from E node B to RNC, we have to find the links. Once the UE has successfully communicated with RNC, meaning we have the RRC connection, we have the radio bearers, etc., then the RNC tells the SGSM that consider the relocation to be complete because we have communicated over the air interface with the UE. The SGSM would have to contact the source system, MME, that handover with the target is complete. So now the acknowledgement is sent in step 13 here. So basically, now the source knows. Source is LTE, target is UMTS. That UMTS target is ready for the UE, and UE has already communicated with the target system. Now, we have to switch the path, because right now our data is going to the LTE system. But since we have already moved into UMTS, the serving gateway should not be forwarding packets to the E node B, should be forwarding packets to the RNC, either directly or via SGSN. So that is the reason that we are modifying the better. Okay. So here is the request to modify the better, and the serving gateway sends the response back to the SGSN. So now the packets would be going from SDW to the UE via RNC and node B. Since we have already moved into the UMTS area, the UE location has to be tracked at the routing area level, and SGSN is responsible for that. So it means we have to do routing area update. Since the UE has already gone into UMTS, MME knows here that UE is no longer in LT, so MME can start the release of LT resources. That's what we are doing here. MME tells the serving gateway, delete your bearer with E node B. It will tell the E node B, delete the bearer with the serving gateway. So now we release the S1 user plane, we release the RRC information, CRNTI that we gave to the UE, all those resources are gone. E node B forgets about the UE. So we lost RRC connection, radio bearers, we lost S1 user plane now. There is no need for those resources. Okay, so that's the handover from LT to UMTS when we use S4 SGSN configuration. Okay, we have one question. Oh, looks like two questions. Okay. Will QoS be lower here handover if the UMTS node B does not have enough research? Oh, yes. See, we do the mapping between the LTQoS and UMTS QoS. Now, if we have some guaranteed bit rates, that for some service we have promised certain data rate, then the target system would reject those EPS bearers if it cannot really guarantee that. So if we have guaranteed, let's say, 100 kilobits per second in LT and we cannot guarantee that in UMTS, then UMTS RNC would reject that specific EPS bearer. It may admit other bearers. Now, if it is a sort of best effort type service, then there is no data rate guarantee on that. So it's probably conceivable that we would downgrade the maximum data rates, and that's quite natural because LTE can have 100 megabits per second and higher, but poor UMTS has to have tens of megabits per second. Okay. So downgrading of QoS is feasible in some cases, and in GBR bearer cases they will be blocked. Okay. A good question. Now there is another comment that from UMTS to LT, MME is not involved. And from LT to UMTS, MME is involved. Okay, let me show you. See, for signaling, handover signaling is between SGSN and MME. Handover signaling is always between SGSN and MME. So we will indeed use S3 interface. So MME is involved in the handover signaling. So let me go back. So maybe we should go to the initial. Yeah. See, now here the U is going from LTE to UMTS, right? So then MME is sending the relocation request to the SGS using S3. So this is LTE to UMTS. Now, if you go back to UMTS to LTE, so this is UMTS to LTE. So SGSN over S3 contacts the MME to relocate the user. So MME is involved in either case, whether U goes from LT to UMTS or UMTS to LT. MME is always involved in the handover signaling exchange. Okay. So hopefully that is now clear. Let's answer some other questions we have got. Yeah, so the question, the comment, okay, will UMTS MSC be notified after successful handover to UMTS? It just depends on what we are doing. If you have just packet switch going on, then no need to worry about that. We can do combined location area update, routing area update. Yeah, that is possible. Then MSC would be notified, so we can send a page message. Yes. So yes, that would be the case. Correct. Then we'll do the location area, routing area update, and MSC will know about that. Another comment, a question. So the RNC may reject some bearer, but admit other bearers such as default. Yes, that is correct. And handover is considered successful. Now, that's your perspective. The glass is half full or half empty. I tend to be optimistic, so I would consider handover to be successful. If you're really picky, maybe it is partially successful. Okay. So if you're looking for some KPIs, key performance indicators, then you should check what bearers we set up, what bearers we could not set up. Okay, good point. But yeah, overall handover is successful, but to a certain degree. Another question: is there packet loss between modify bearer? Actually, there is no packet loss if we have packet forwarding, because what would happen is we have the sequence number, and until we have switched the path, right? We are ready to switch the path from one technology to another. We would continue forwarding the packets. So when we send the last packet, then we tell the source system, this is the very last packet. So we have the marker, we have end marker packet. So we tell the source system, this is the very last packet I am sending you. So after that, the source system will forward the remaining packets, and in future, the packet will be going to the target system. So zero packet loss. Okay, zero packet loss if we have packet forwarding. Okay. Very good. Let's talked about that. Okay. So we looked at handover from LTE to UMTS, UMTS to LTE. Then we have S4 SGSM, meaning SGSM that has been upgraded to understand the LTE. Okay. Now, let's briefly talk about interworking between LTE and GSM, meaning SGSM has not been upgraded to understand LTE. It does not know that it is talking to serving gateway or MME, etc. Okay. Let's see, we are reaching almost 10. Okay, let's have a short break and then we will take care of the release, pre-release SGSM and interworking between LTE and GPRS-H. And to then we will summarize what is so-called ISR, idle state signaling reduction. Okay, so let's have a break, 10 minutes. So we will welcome back. We have got a couple of questions on live meeting. One is a handover request will not be rejected due to no resource. Maybe the target should send the acknowledgement and we can reallocate the resources based on QCI. Is that correct? Okay, now first of all, let's forget about LTE. Okay. Think of current commercial networks. So in a cell, we have a limited amount of radio resources. We share those radio resources among active users and the handover users. Now we normally reserve some amount of resources for handover users. So when a new call comes in, that cannot use the handover related reserve resources. But if a handover call comes in, then it can succeed because the new call could not access some of the handover resources. So from that perspective, handover does have higher priority compared to new calls. However, we cannot just drop the existing calls, existing sessions, because they are already admitted. And if you drop bearer or something like that, then it is perceived as a very bad quality. So in general, we should not drop or release the existing bearers, if possible. Now, you do have a valid point in that we should consider the priority of different services, etc. And from that perspective, let's say if we have two handover calls, one handover call is for high priority QCI, another handover call low priority, then we should prioritize the high priority handover first. So yeah, there should be some level of priority given to handover compared to new calls. And the reason that we do not want to drop the existing bearers is perceived as poor quality, something like call drop. Now, having said that, exactly what to do for new call, handover call, should we downgrade something, should we completely release some bearers, that is all implementation specific. So Alcatel-Lucent, you guys would have one solution, one proprietary algorithm. Ericsson would have another proprietary algorithm. So it depends. because it's implementation specific. But in general, you do not want to release the bearers. Probably you can save some resources by downgrading the maximum data rates. Probably that is a good thing to do for some kind of bearers. But after all, even after you do all this, there may still be some limited resources. So indeed, standard does support so-called handover reject. Okay. So that is answer to one of the questions there. Do we really have reject? So yes, there would indeed sometimes be reject. You would try to avoid that, but sometimes simply we run out of resources. Another question. Let's say we have reject. So will the handover will be failed, or we have to find another target? Because we did not discuss any second better candidate type scenario. Okay, so here is the situation. The UE has sent a measurement report, and accordingly, the source system chose a specific target base station, target RNC or target E node B. Now, when we decided about the target, we considered the measurement report. Now, if that fails, then in one of the simplest scenarios, yes, the handover would fail. Now, what do we do? If there is no resources available, then what do we do? Now, one possibility, the simplest scenario is just drop that, reject the handover. So our UE basically has to find another cell and we can retry with that. Okay, but that is dependent on a lot of factors. Is the UE able to find another cell or not? If we have received the measurement report in the past that has more than one E node base controlling the reasonably good enough cells, then we could, in an implementation specific way, it is not in the standard. We could, in an implementation specific way, try another E node B. But from the initial handover perspective, yeah, the handover has failed, but we may try to do some kind of a fallback to another E node B. But that is again implementation dependent. So in the simplest case, yeah, handover has sort of failed. Okay. But those answers to those two questions actually depend on the implementation. Okay. So standards do not say exactly what to do. Standard just describes a simple scenario where there would be handover reject. The handover decision is taken for B1, B2 similar to EHRPD. Correct. So for handover between two carrier frequencies of LTE, handover between LTE and another technology could be UMTS, GPRS, 1X video, does not matter. We still have the same two events, B1 and B2. That is correct. Okay, thank you for your questions. Let's move forward. Now we will talk about how we can have interworking between LTE and UMTS where SGSNs are left untouched. So they are still supporting old interfaces. They do not understand LTE. Now what will happen? Okay, our UE currently communicating with the LTE system. So we are talking from LTE to UMTS kind of handover. So we are with the LTE system right now, and based on the measurements coming from the UE, the E node B has made handover decision that some primary scrambling code of UMTS is giving pretty good ECO and not. So based on that, E node B has made the handover decision. It asks MME that, okay, let's do the handover to UMTS. Now, the MME would contact SGSM that is in charge of the identified RNC. Now, look at this interface. See, this is GN SGSM. So it does not know that it is talking to MME. So from SGSN perspective, it is just talking to another SGSN, and this is handover signaling for handover between two SGSNs. So there's the view of the GNSGSN. So then the SGSN works with the RNC. RNC will make sure it has the resources available. If it has, it would admit the call. It would accept the handover request, and the forward relocation response is sent back to the MME. Since the resources are available here in the target, the handover command is sent to the UE. So next, the UE receives over their interface RRC message, mobility from EU TRAN, and then it will try to connect with the target UMTS system. In the meantime, we would inform the target system that we have already sent the handover command. There's the forwarding of the serving radio network system context, so that will find its way through the RNC. Basically, what is happening here is that we have IP packets coming to the radio network, and we give sequence numbers, PDCP sequence numbers. That's the topmost layer in the protocol stack for user traffic, and we give sequence numbers. So we are just telling the RNC about the PDCP sequence numbers, the packets that we have successfully sent to the. You guys still there? I heard some kind of beep. Can you send a quick acknowledgement? Okay. Yes, you are there. Good. Yeah, I heard some beep, so I got worried.
We're here.
Okay, good. Thank you. Okay. Yeah, I'm on the landline phone. There should not be any call drop. You never know. Okay. So the PDC sequence number is sent to the RNC so that we know what is the next sequence of the packet to be sent to the UE when the handover is completed. Now, in the meantime, our UE is contacting the target UMTS system. Once we have our RC connection and the radio access bearer set up, then we would inform the SGSN that relocation is complete. We have communicated with the UE over their interface. SGSN tells the MME, okay, relocation handover is complete. Since the relocation is complete, we need to ask PGW, do not send packets to the serving gateway. UE is already with the UMTS system. So we are now updating the PDB context. Remember, this is GNSGSN. So it does not know about serving gateway, right? So when you physically connect SGSN to the PGW, it thinks that, oh, it is talking to GGSN. And that's the reason we have to update the PDB context. So in future, the packets will be coming from the outside world, PGW GGSN to the SGSN all the way to the UE. Since the UE has already gone into UMTS target system, then no need to hold on to the LTE resources. So we release all the LTE resources, S1 user plane, radio bearer, S5, and so on. So as you can see, it would work whether we have S4 SGSN or GNSGSN. Standard supports both. So in an operator's network, maybe some areas we have S4 SGSN, some GNSGSN. That is not an issue. Some features such as ISR, they are available only with S4 SGSN. That's the reason we say that performance could be slightly worse in GNSGSN. The overall IP connectivity, all those things are supported by both S4 SGSN and GNSGSN. Okay, let's take care of this quick poll. I will give you 1 minute to finish up this one, and please participate in the poll. No penalty for a wrong answer. I hope you do not have to guess, but you have to guess the answer, no problem. you will still get the credit. So please participate. Very easy, think and click. And I will give you a hint. GNSCSN does not understand LTE. It has no idea of what evolved packet system is. It has no idea. As for as GSM, yes, that knows about LTE. It knows there is serving gateway. There is MME. But GNSCSN, it has no idea about something called LTE, something called EPS. It has no idea. So hopefully that hint would move you toward the correct answer. And we are looking for a true statement, not false. True statement, which is correct. Ten seconds. Make up your minds. 10 seconds to go. The clock is ticking. Decision time. Okay, let's see what you guys are telling me. Okay, about 60% got it right. Direct forwarding. Direct forwarding means we are sending the IP packets, okay, between two nodes, from E node B to RNC, RNC to the E node B. No other node involved. Now, if you have SGW involved, it is called indirect forwarding, right? Now, that doesn't need to be more than one SGW. One serving gateway good enough to be qualified as an indirect way of forwarding. So, if there is no direct channel, no direct connectivity between E node B RNC, then you can either use one SGW or you can use the help of SGSN and serving gateway. It depends whether you have direct channel architecture or not. Okay, now we have to worry about 2.5G technology also, because maybe in some geographic areas UMTS has not found its way. Okay, so let's talk about that. Now, if you just look at the standard, then standard is quite flexible. Standard says that you can go from connector state in LTE to packet transfer mode. This is like connected mode in GPRS edge. You can go RRC idle, and packet transfer mode, so you can go from, let's say, RRC connected to packet idle or packet transfer mode to RRC idle. A lot of things are possible. You can go from RRC connected to idle mode and then you will transition into transfer mode. Now, if you go connected like this, RRC connected packet transfer mode, that's the true packet switch handover, but do not expect that to be common, because we do not have packet switch handover in a basic GPRS edge. Forget about interworking. So what you would see most likely happening in the commercial networks is this approach. So we are talking to the source system here, LTE, in the connected mode, and then for handover, it's not really handover, but for, let's say, mobility into legacy technology, we will send a command, cell change order. So we will tell the UI go to GPRS. And then there is one very nice feature available called NACC, Network Assisted Cell Change. So we'll talk about that. So if there is no packet switched handover, this is the next best thing to happen, optional NACC. And idle mode, these you can also expect to be quite common, idle to idle. So we'll talk about cell change, and we'll talk about idle mode mobility. Okay, those are the two scenarios we'll take care of here. Here is idle. So we are currently talking with LTE. Okay. And then the UI is moving outside the LTE coverage. So we have to do handover. We have to switch the UI to another technology, GPRS. So to help us do that, we would have signaling exchange between the E node B and BSC here. And that signaling is called RAIN signaling. RAN Information Management Signaling. RAN is Radio Access Network. And the idea behind that is that we want to transfer system information about target system GPRS H, Radio Access Network. Let's say there is no RIM signaling. Then what would happen? Then in that case, when we ask UI to go to another cell, let's say some cell in GPRS Edge, then poor UI has to do synchronization, it has to read all the system information, it may take several seconds. So we have a pretty long handover delay before we can resume the data transfer. Now we want to avoid those seconds type delay. We want to be closer to hundreds of milliseconds rather than seconds. So we said, okay, how can we do that? To help us do that faster so-called handover, we have this RAIN signaling. So when we have the UI moving outside LTE coverage area, before we send the handover command, we will exchange information between source and target so that system information is given to the E node B. And the E node B will put that information inside the handover command, network assisted cell change system information. So now our UI, after going to the target GPRS cell, does not need to waste time looking for system information. So we saved precious seconds. That's the beauty of RIM signaling. Now the RIM signaling actually is between the E node B and the RBSC, but they cannot directly talk. So they have to go via their core networks. So E node B has S1 MME interface here, MME has connectivity with SGSN, could be S3, could be old GN connectivity, does not matter. And then we have the SGSN talking to the BSC via GBIU interface. So the RIM signaling is transparently processed, is transparently conveyed by the core network elements. So only the endpoints would open up those messages. So E node B and BSC. So in summary, when we are going from LTE to GPRS H, Then we send the handover command. Inside the handover command, we will have this cell change order, and to reduce the handover delay, we also have network assisted cell change, where we rely upon the ring signaling to provide system information about the target. Now let's talk about the idle mode mobility. In the idle mode, the UE does not have any radio connection, so we are just doing the cell reselection. The UE is observing system information blocks. So for LTE, when the UE is inside the LTE net coverage area, it will be looking at SIP 6 and 7, and they will be giving information about 2G, 3G neighbors. And if UE is in the U-turn coverage area, then SIP19 will give LTE neighbor information. If the UE is in the GE-run coverage area, SI2 queter would give the UE information about LTE. So basically, whatever radio access technology the UE is currently on, that radio access technology would be giving information about the technologies available in that neighborhood. So we have given some examples here. So for example, if we have UE observing the downlink of some LTE cell, then we need to know 2G, 3G neighbors, and they will be available SIP 6 and 7. There will be some timers before you can reselect one of the technology. Those are the timers, because you do not want to have ping pong between two technologies. So once you go to one technology, you want to make sure that you stay there. So there is some threshold, there is some hysteresis values given, and the timer. So basically, the new technology has to give you better signal for certain timer. So you want to make sure that the new technology that you are about to tune into stays better for a reasonable time period, maybe a couple of seconds or a few seconds. Similarly, if you are, let's say, in the UMTS coverage area, then you are observing the downlink coming from UMTS node B. So here our interest is looking for LTE neighbors, and that information is given in the SIB number 19. So SIB 19 tells us how to look for LTE neighbors. You can prioritize different technologies. So of course we will use this common sense. LTE higher priority than UMTS, and then GPRS edge would have the lowest priority. So you can specify different priorities for different frequencies. So one frequency LTE, another frequency UMTS, yet another GPRS, something like that. If we are in the GPRS edge coverage area, then our device is looking for LTE and 3G neighbors. So here, for example, in LTE case, we will have information on the carrier frequencies where LTE is deployed, as many as 8. In the initial deployments, 1 or 2 is more than good enough. And EU-TRAN can be given highest priority. Okay. Now, let me give you a very nice example of how we can do the cell reselection between two technologies. So currently, our UE is observing LTE cell. Okay, that's our serving technology, LTE. So we are in the idle mode, so no RRC connection. Radio network has no idea about our existence. Only the MME knows about us. and MME knows the UE location at the tracking area level. Okay, so our UE is currently looking at LTE cell, and periodically it is looking for other technologies. Could be UMTS base station, could be GPRS edge base station. So we are moving away from the LT coverage area. So this is LT, and in the nearby area there is no LT. So perhaps some 2G, 3G technologies available. So now what do we do? Here the LTE signal strength, RSRP, keeps going down. It is becoming weaker and weaker. So at this point, the LTE signal strength, RSRP, drops below as non-intra-search. Meaning, if the UE stays above that threshold, no need to look for another technology. Health is very, very good. But unfortunately, in this example, our UE observes that the LT RSRP is below that threshold. So now we should start looking for other technologies, because LT probably not the best one. So let's see if something better is available. So now the UE looks for another technology, and it knows from SIPs 6 and 7 which are UMTS neighbors, which are GPRS edge neighbors, and so on. So our LTE RSRP continues to drop, and in the meantime, perhaps a UMTS cell is becoming better and better. So at some point, at this point, the UMTS is better than this threshold. So UMTS is becoming stronger than a threshold. So you could say if your I not greater than perhaps, let's say, minus 9 dB or something like that. At the same time, our LTE has dropped below this threshold. So LTE RSRP is less than a threshold, which is this one. Okay. So LTE is becoming weaker than a threshold, and UMTS is stronger, greater than threshold. So it means that at this point, UMTS stronger and LTE weaker. So if that condition persists for this timer for reselection, then we stop looking at LTE and we start observing the detected UMTS cell. So in summary, when the LTE drops below a threshold and UMTS becomes better than a threshold, for the duration of this timer T-reselection, the UE performs cell reselection, and then it starts observing the newly detected neighbor, maybe 3G neighbor, maybe 2G neighbor. And let's take another example the other way. So in this case, our UE is with UMTS. Okay. And let's say this is UMTS, node B. Now the UE is entering the area where LTE is available. So earlier we were in UMTS only coverage area, but now LTE is also becoming available. That is the situation we are discussing here. Oh, cannot hear anything. Oh, someone cannot hear. Can you guys hear me? At least some of you? Please type yes or okay or something. Oh, okay. So looks like this is a local problem. Oh, thank you, thank you. A lot of positive acknowledgements. Very good, very good. You guys are awake. Thank you for staying awake. We do not provide tea, coffee, anything like that. You are still awake. That's very good. Okay, so whoever cannot hear, please check your phone, your connection. Okay. The good news is that we are recording. So if you have lost a little bit, you can catch up later. Okay. So here we are going from UMTS to LTE. So we have been observing the downlink of UMTS in the idle mode, but now we are entering the LTE coverage area. So now what is happening is that our LTE RSRP is becoming greater than a threshold. So LTE is strong enough. And then we want to make sure that we do not just detect strong signal only once. That situation persists for the duration of the timer. So we check again. Okay, better, still better. It sounds good. Time to do the self reselection to LTE. And since LTE is higher priority technology, you can rest assured that it will be looked for at least once every minute, once every 60 seconds. Okay. So high priority technology is searched at least once every 60 seconds. Maybe faster, but at least once every 60 seconds. So as soon as the UE enters LTE coverage area, within about a minute or so, we could lock onto LTE, and then we can do the cell reselection. So hopefully you got a good overview of how cell reselection occurs between LTE and non-LTE technology. Again, similar idea for not handover, but cell reselection between the GPS and LTE. So right now we are observing the downlink of GPRS edge, and the LTE is becoming the better quality technology because we are entering the LTE coverage area. So in that case, let's say LTE better. At this point it exceeds the threshold, high priority threshold. And then we want to make sure we stay better for the duration of the timer. So at this point, we do cell reselection and we start listening to E-node pin. So in summary, in the idle mode, our UE has no radio connection, no dedicated radio connection. So it is only observing the downlink system information, things like that in the source technology. So if LTE becomes available, then we do cell reselection to LTE. And if we are moving outside the LTE coverage area, Then whoever 2G, 3G is available, we will start listening to that non-LTE technology. Okay. So I promised this ISR that it would be coming toward the end of the session. So that's what we would talk about now. Now let's see, there was some question perhaps. Oh. Now, if you have a specific question, if you missed maybe just a few minutes, then let me know. Okay. Tell me what slide you want me to go through, and then I will briefly summarize that. Okay. Okay. So let's talk about this ISR, idle state signaling reduction. Here is the basic idea. Oh, okay. Before we move forward, maybe we should take care of the question. In case of handover from LTE to UMTS, E node B should provide RNC ID, correct? So does it mean it has a table that maps to RNC? Yes, that's correct. So it has the table. We need to configure the E node B with some kind of table that maps the UMTS cell, carrier frequency, primary scrambling code, some kind of identity for the cell. And associated with that UMTS cell, there would be some RNC that is in charge of that UMTS cell. So yes, we should have that kind of mapping configured. That is correct. Because the MME will contact that specific RNC. So we need to have that kind of mapping. So based on the measurement report, the E node B will look at the table that, oh, this measurement report contains UMTS primary scrambling code number 10 on this carrier frequency. It means that that is controlled by this specific RNC. So yes, that information needs to be configured. Okay. Idle state signaling reduction. So we'll spend the next few minutes on this. Here is the idea. Let's say, first I will give the motivation. Let's say our UE is switching back and forth between two technologies. Let's say LTE technology and UMTS. Okay. So it moves into UMTS coverage area, it goes outside the LTE coverage area and things like that. Okay. In and out of LTE coverage area. So what is happening is, if UE goes into LTE coverage area, it has to do tracking area update. If UE gets outside the LTE coverage area into the UMTS coverage area, then it has to do routing area update with SGSN, tracking area update with MME. So there would be a lot of signaling if the UE goes back and forth between technologies. So if you want to avoid excessive signaling in the idle mode, then we can activate a feature called ISR. ISR means idle state signaling reduction. So it means that in the idle state of the UE, we want to reduce signaling load. So we want to avoid these very frequent tracking area and routing area updates. So here is the basic idea, how to implement. Let's say the first time we do attach operation, we get GUTI from the MME, and we have the UE registered in a specific tracking area. So MME knows about the UE, and MME knows that UE is inside tracking area identity number 1. Now the UE goes into UMTS only coverage area. So there is no LT to be found. So when we go to SGSN, we will do routing area update, because we need to tell SGSN that okay, here we are. So routing area identity, and SGSN would give the UE packet changing. Now, when we go into the SGSN area, we already have the GUTI. So now we can activate ISR. We can tell SGSN that okay, we came from MME, we already got the GUTI in the past. So now, when we activate ISR, the UE is considered to be registered in both LTE technology and UMTS. So we have both identities. We have GUTI for LTE, we have packet TMZ for UMTS. And there's the two identities we need. So we need to just tell the core network that okay, here we are in this tracking area, this routing area. So if you just go back and forth between two technologies, you do not need to tell the network whether you are in UMTS coverage area or LTE, because you already got GUTI, you already got PTMZ. And if we need to send a page message to the UE, page message would be sent in both the routing area and the tracking area. So if we want to send a page for some packet data service, SGSN would send page from all the node Bs in the routing area, and the MME would send a page message for the UE in all the E node Bs in the tracking area. So if the UE happens to be in LTE coverage area, it would respond to page from LTE. If UE happens to be in the UMTS only coverage area, then it would be responding to the page message in the UMTS coverage area. So we have now significantly reduced the signaling load, because from the core network's perspective, it only needs to know the tracking area, the paging area, or the routing area. And we already know that at the SGSN, at the MME. So that's the beauty of ISR, okay, that we are allowing UE to go back and forth without worrying about doing the tracking area and the routing area update. So how to implement? Let me talk about the call flow for that. So our UE is currently doing the attach operation with the MME. So the temporary identity to be used in the next update is GUTI, because the only ID we have is GUTI at this point. Now we are in the idle mode, so let's say we do cell reselection, and as part of cell reselection, now we are talking to the SGSN now. So we send this routing area update message, okay, and we tell the SGSN that oh, we already have GUTI. So SGSN knows that oh, this UE already talked to MME in the past. So let me confirm with the MME that okay, ISR capability, yes, we can do ISR activation, and SGSN can activate ISR by sending the routing area update accept message, and here we trigger ISR. So what is my identity now? Identity is rate related things. So if we happen to monitor downlink of UMTS, we think that we already have three things. If we happen to monitor LTE downlink, due to salary selection, we assume we have GUTI. So we have basically both the identities available. So we will not need to do tracking area, routing area update any longer. So that's the idea, that we have considered the UE registered both in the LTE domain and the UMTS domain. Okay. Let's take care of the questions that we got. Okay, so when the UE goes from LT to UTRAN, we we do the whether we do tracking area update or routing area update, that depends on the target. Where are we going to? So if we go from LT to UMTS, so we are going into UMTS, then in UMTS we have to do routing area update. If you go into LT, so we are going to MME area, then we have to do tracking area update. So target, where are we going to? Depending on that target technology, we decide tracking area or routing area update. Okay. So in your question, if you go from LT to UTRAN, then from UMTS perspective, you need to do routing area update. Okay, routing area update. Now, what about an incoming call from PSTN? How will UE be paged? Okay. Now, we have only talked about this packet switch scenario, right? Now, if it is a voice call, then it depends on what the exact situation is. So I will give you one real world example. So let's say we want to use voice over IP in LTE, but we want to use CS call in UMTS because we have circuit switch core network. So in that case, if you recall from one of the previous sessions on voice services, then you would remember that when we do the attach operation with LTE, that would be sort of combined attach with LTE, attach with IMSI, attach with MSC. So MSC knows which MME is responsible for that UE. So when we want to send a page message, then MSC would send a page message to a specific MME, and that MME would send a LTE page message, and the UE, if happens to be in the LTE coverage area, it would get page from some tracking area, and then we can take care of the voice call. So that would be one real world example. So in that case, we will be able to send the page to LT. Okay. And this is MSC, right? So if we go into, let's say, SDSN routing area, then we can do combined sort of location area routing area update. So if you support that, then basically MSC knows about SDSN as well. So maybe MSC can then send a page to MME, and it can send a page to SDSN either way. But probably MME would be preferred. It would be up to the MSC at that time. But in one common example, MSC can send a page to the MME. MME will send page from all the node base in a given tracking area. That would be one valid scenario. Okay. Good question. Let me ask you a couple of questions here. Easy question. True or false? 50% chance of getting it right. Hopefully it's close to 100%. please participate in the polls. 1 more minute. 60 seconds. And what is 60 seconds? LTE will be searched at least as often as every 60 seconds if the UE happens to be in a non-LTE coverage area. To begin with, so if the UE is observing UMTS downlink or GPRS edge downlink when it is in the idle mode, then at least every 60 seconds it will check, is there any LTE around? Okay, 30 seconds left. Okay, the statement is true. We will be sending the page message in both the UMTS area and the LTE area. There's the idea, right? You want to minimize tracking updates, routing updates. So you do not know. The network does not know. Is the UE really in the tracking area? Is the UE really in the routing area? The only thing network knows is UE may be in the tracking area. The UE may be in the routing area. So we just send a page in both the technologies. So wherever UE is, UE will respond. One more question coming your way. And here we are focusing on the terminology, okay? Terminology. So reselection, cell reselection. Is that the term we use for active mode or idle mode? Ten seconds to go. Again, this is just a terminology question. We support mobility in the connected mode, idle mode. Let me share the results. Almost 70% got it right. It is true. See, in the connected mode, if you go between two technologies, it is typically called handover. So connected mode, we call it typically handover. And if the UE is in the idle mode, and if we go between two technologies, it is called cell reselection. Okay, cell reselection. Okay. Let's summarize what we learned today. So basically, to have interworking between LTE and 3GPP family of standards, we have two basic options: either upgrade SGSN to understand new LTE interfaces that ask for SGSN, and if you do not touch SGSN, then you can still have interworking, but it will be through G and SGSN. So as for SGSN means we have support for S4 interface between SGSN and SGW. SGW is the mobility anchor in that case. S3 would be the signaling interface with MME, and this is the HSS connectivity. If you go back and forth between two technologies, then we have to do the mapping between the PDB context and the EPS bearer. And if you have interfaces, new interfaces supported, if you do packet forwarding, then you will have minimum disruption. Idle mode, we are doing cell reselection that is based on the system information. Okay. So finally, we looked at ISR. We are basically saving the processing power, the UE battery life. No need to do tracking area, routing area updates if you just go back and forth between two technologies. Okay. One final note before I let you guys go. Okay, now when the UE is in the connected mode in a given technology, then we need to give UE some way such that UE can make measurements of another technology. So let's say UE is in the connected mode. Okay, so the question is, how do we look for other technologies? Okay, so let's say the UE is in LTE. Okay, so it is talking to E node B, and now it is moving outside LTE coverage area. So in that case, it needs to detect the other neighbors. Could be 2G neighbors, could be 3G. Now, how does the UE in the connected mode look for other technologies? We have DRX, discontinuous reception. So we create measurement gaps. Okay. And during those gaps, the UE can look for other technologies. So LTE and non-LTE, it can look for other technologies. Okay. So it's no longer on LTE during these highlighted time periods. Okay. And when the UE has detected good neighbors, it would send a measurement report indicating what it has detected, and that is event-based events B1 and B2. Okay. Same as what we discussed for EVDO interworking. If the UE is in UMTS coverage area, so it is talking to some E node Bs, one or more node Bs, and then maybe it is moving into a coverage area where LTE is becoming available. Then how does the UE look for LTE? Here we have compressed mode, and basically they're still the same. We create some kind of gaps. So UE is on UMTS normally, and once in a while it will go to LTE frequency and make measurements. Finally, if UE is in GSM-GPRS edge, looking at some base station, and when can it look for LTE? So we have idle frames because we have TDMA, and during the idle frames, the UE has opportunity to look for other technologies. Okay. So I just wanted to make sure that you are clear on when and how to look for other technologies when the UE is in the connected mode. Let's address the questions that we have got, and then we will let you go. What is the trigger for ISR activation? Trigger for ISR activation, very simple. We have registered with one technology in the past, and then as soon as we register with the second technology, that is the trigger. We have old technology and the new technology. Now both technologies should know about the UE, so that is the trigger. So for example, if we have done tracking area update in the past, so MME knows about it. So if you start doing routing area update, then you are now going with second technology. You already have communication with one technology, now you have second technology. That is the trigger. Any disadvantages? The only disadvantage is that we have to send a page message in two areas. That is the disadvantage. For ISR, when will the UE check its location and serving cell? That's basically periodic, right? It is following some sleep cycle. So it is waking up periodically, looking for system information. And in the system information, it says, I am in this new tracking area, or I am in the new routing area, things like that. So it is just following the sleep cycle in the idle mode. Event A3, A5. Oh, you have question about event A3, A5. Oh, I see. Okay, event A3, A5, that is for intra LTE, same carrier frequency mobility. So we should have that covered in one of the sessions in the previous series. But let me just summarize. A3 basically hysteresis thresholds are used. Oh, actually this is just, okay, this is good enough. Okay, so A3 says effectively that neighbor is better than the serving cell. Okay, this is intra LTE. You are just going from one node to another, one cell to another, but the same carrier frequency. So neighbor is becoming better than serving cell by certain amount. Sorry, my handwriting, I'm writing fast. So maybe 4 dB, 5 dB, something like that. So if neighbor cell becomes better than the serving cell by certain amount for certain time period, then event A3 occurs, and the node B will execute the handover algorithm. Probably it will decide that you should go to the neighboring cell. Event A5, I hope I remember this right. Serving cell drops below a threshold, and the neighboring cell is better than threshold. So neighbor is becoming better and serving is becoming weaker. So maybe this is below minus 95 dBm RSRP, and neighboring RSRP is, let's say, better than minus 85 dBm. So when those two conditions are met, then event A5 occurs and the UE will send a measurement report. Okay, so those are A3, A5, and you can check accuracy of this. I hope this is right. 36.331, that is the RRC specification. You do not need to read the whole standard. Just look at the table of contents and you will see those events summarized in one or summarized in just a single statement in the section title itself. So that is very easy. Okay. A couple of more questions. Yeah, sorry to keep you waiting just a little longer. Please have patience. We want to answer the questions. Okay. From the wiretap trace, paging DRX V32. Paging DRX.V30. I do not know about this paging there V32. So I need to check. But basically, what you should see, there may be some kind of mapping, okay? That how frequently the UE is waking up. So is it every 100 millisecond, 200 millisecond? So in the attached request message, we tell basically the node that, oh, this UE is waking up every X milliseconds. So UE can be sent a page message when the UE really wakes up. So that is the reason. But send me email and I will give you the exact reference. Okay, and I will find out the exact numerical value. There may be some kind of mapping between so-called V32 and the actual milliseconds, how frequently UE wakes up. But basically, paging DRX means that UE is waking up periodically to look for a page message as often as certain milliseconds. So this V32 probably corresponds to certain milliseconds. Will UE increase its power in the DRX mode? No, in the DRX, UE is just listening. Discontinuous reception. So we are not transmitting anything. So we are just listening. So no need to increase the transmission power. We are not even transmitting anything. Is there an event like B1, B2 for LTE UMTS? Correct. See, events B1, B2, that's what I was mentioning here. See, event B1, B2, that is going from LTE to maybe UMTS, maybe EVDO, whatever. One carrier frequency of LTE to another carrier frequency LTE. Okay. And going from LTE, sorry, the other way. Give me a few more seconds, please. UMTS to LTE. I think there are events 3 something, 3 A, B, C, D, something like that, and they say that LTE is better than UMTS. Okay. We have answered all the questions. Thank you very much for staying a little longer. So, if you could please send evaluation to the students, Peggy.